All right, so we're going to be looking at graphing, and notice we're looking at graphing a square root. Right away I see the square root there, and I'm thinking to myself, okay, I know what the shape of a square root. There it goes. It's half of a sideways parabola. Whether it goes in that direction or the other direction, or whether it's upside down, but the graph of a square root just looks like one of those. So now let's just go ahead and think through this. You want to think through, how do you get 0 underneath the square root there? So I'm thinking right underneath the square root, how do I get 0? I get a 0 there when x is 0. Now, interesting enough with square roots, remember you cannot take the square root of a negative number and for it to actually get a real number out of that. So do not take the square root of a negative number. So in other words, I could not choose -1 because I can't take the square root of -1 and get a real number that I actually can graph out here. So I'm going to pick the next larger number up from 0 there. I'm going to pick 1. Can I take the square root of 1? Yes, I can take the square root of 1. And I'm also going to pick a nice numbers that I actually can take the square root of. So remember kind of your list here. You can take the square root of 0. You can take the square root of 1. 2 doesn't come out nice. 3 doesn't come out nice, but 4 does. And then the next one here would be 9. And then if you kept going, it'd be 16 next. So I'm going to go ahead and pick some of these here. Actually, let's just pick them all. Let's pick all those. So if we do those, the square root of 0 there is 0, minus 3 is -3. The square root of 1 is 1, minus 3 is -2. The square root of 4 is 2, minus 3 is -1. The square root of 9 is 3, minus 3 is 0. Square root of 16 is 4, minus 3 is 1. So let's plot that out. We've got -3, and we got 0, -3, and we've got 1, -2. We've got 4 and a -1. And then we got 1, 2, 3, 4, 5, 6, 7, 8, 9, and we've got 0. So 16 is not going to fit on my graph there, but these will. Not doing a great job of graphing that out. Sometimes it's hard to do that up here, but there it's looking. It's not a line, it's a curve, so kind of make it look curvy like. And usually if you kind of start here, you can kind of, it starts up a little and then goes off, but just a tad. So sometimes you have to curve it quickly. All right, so now let's come over here and let's look at the other one. Same thing. You want to think, how do I get 0 inside there? How do you get 0 in there? And if you don't see it, you can just take what's inside there and set it equals 0. So then I'd subtract 1, and x equals -1. So that becomes my starting point for square roots there. You have to start at that point. You're not going to pick one before and after it. But for the other functions, we did that. We picked them before and after. So now I'll think about that. -1 plus 1 there is 0. Square root of 0 is 0. And 0 times 2 there is going to give us 0. Now we're going to pick something after -1. So not before, because I picked before, it'd be -2. -2 plus 1 is a -1. And I can't take the square root of a negative and get a real number. So I'm going to pick something after -1 like 0. 0 plus 1 there is 1. Square root of 1 is 1. So 2 times 1 there is 2. So now I could pick the next number of 1, but 1 plus 1 is 2, and it's hard to take the square root of that. So I'm going to keep going. 2, that is 3. No, I can't take the square root of that. Then I'm going to put in 3. 3 plus 1 is 4. I can take the square root of that. So I'm going to plug in 3. So 3 plus 1 there is 4. Square root of 4 is 2, and 2 times 2 there is 4. So then keep going until you've got to be able to take the square root of 9 here next. So we know that number has to be an 8. So 8 plus 1 there is 9. Square root of 9 is 3. So 2 times 3 there will give us 6. So let's plot those points. -1, 0. We've got 0, 2. We've got 3, 4. We've got 8, 6. And then plot those. Hopefully you guys are doing a better job than I am at those, but that's okay. That looks pretty good. So I went up a little bit and then I curved it up. So there's our square root functions. Again, they kind of look like got a dot here, goes up, kind of a half of a sideways parabola. All right, and then we have these. Remember, these are a little bit different because usually you've got two parts to this. Might be something like this and something like this, but you've got two parts. So when you're graphing these are a little bit different here, except still we're trying to figure out how do you get 0. So down here, you got to think, how do I get 0? Well, you get 0 down there when x is 1. But notice I put 1 in there. If I put 1 in there, 1 minus 1 there will give me 0. But 1 divided by 0 is undefined. We can't divide by 0. So that's actually going to be our vertical asymptote. We need to know what that is. So I'm going to abbreviate vertical asymptote there as VA. So we need to know what that is. Our vertical asymptote there is at x equals 1. So then I'm going to plot this in here, and it's going to help me to graph this out. So my vertical asymptote is a vertical line, and it goes over there at 1. So I just drew in a vertical asymptote. It's going to divide my graph there for me. So let's come over here and let's do our table. So since it's dividing our graph there, you want to go where I put the graph there. So thinking about this right in here being my asymptote here, you want to pick x values there on the left side of that red line, and you want to pick x values on the right side of that red line. So I'm going to pick 2 or 3 there on the left-hand side. So maybe like 0. We've got -1, and we've got, well, let's just do 3 for now. So then that splits it, right? And then you pick 3 to the right of that red line as well. So what would that be? 2, 3, and 4. And then we'll just simply plug them in there. So if I do that, I've got 1 over, if I've got to do the bottom there, so 0 minus 1 is a -1, and 1 divided by -1 is -1. Then I've got 1 over, -1 minus 1 is a -2, so that just gives me a -1/2 or -0.5. Then I can put -2 in there. -2 minus 1 is a -3, so I simply am getting the -1/3 or a -0.33333. All right, now let's plug in 2. So 1 over 2 minus 1 is 1. And then 1 over 3 minus 1 is 2. So that's just simply half. And then 1 over 4 minus 1 is 3. So I simply get 1/3. All right, let's plot these points. So over in this section over on the left side of that red asymptote there, you got 0, -1. You've got -1, and then down -0.5. Whoops. Oh, ain't bad. And then I've got -2 and then a third, -1/3. So doing something like this. All right. So there is part of my graph. Now let's graph the other one. This one is 2 and 1, 3, and then up 1/2, and then 4 and up 1/3. So how does this graph is? It's going to get closer and closer there, and then this one's going to get closer and closer out here to that asymptote. It's getting closer and closer to the x-axis, and this gets closer and closer to the vertical asymptote up there. All right, so then we've got one other one to do over here. Again, I can see it's 1 over, and you got to x down the denominator. So I'm thinking, it's going to be kind of that split kind of a graph again. It's that rational reciprocal function there. So again, we got to start right here. How do you get 0? You get 0 there when x equals -2. So what does that mean? That means my vertical asymptote there has to be at -2. So let's draw a vertical line there at -2. So, and then I'm going to pick some x values. I'm going to pick them to the left of that vertical asymptote, and I'm going to pick them to the right of the asymptote. So -3, -4, -5. And that's going to split it, and then I've got a -1, 0, 1. So I picked 3 x values, just kind of looking on the x-axis, what value is this, 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 and then I'm going this way. Those aren't really dots on your graph, but they're helping you to figure out your x values. I'm picking those. Then you just plug them in there. So it's 1 over -3 plus 2 is -1. 1 over -4 plus 2 there is -2, so you get a -0.5. And then 1 over -5 plus 2 there is a -3. Then down here at the bottom, 1 over -1 plus 2 is 1. Putting in 0, 0 plus 2 there is 2. And then putting in 1, 1 over 1/3. Let's plot this. So these aren't really on there. I'll get rid of those. So -3 and then -1. And I got -4 and -0.5. And then I've got -5, -1/3, and then connect those. I'm going to do the same thing on the other side over here. -1, 1 is 0 and up 1/2. 1 and then up 1/3. Connect those. Not very good, but hopefully you get the point of how those connect there. Getting closer and closer to the x-axis to the right there, getting closer and closer up this way as it approaches that red horizontal line. All right, so we have those graphed out. Now these here are just a simple matter of interpreting the graph. It says find f of -4. They're actually saying we want to find the y value when x is 4. So when x is -4, what is y? All right, so find f of -4. They're asking you to find the y value there when x is -4. So x is -4 right over here. So where does it hit the graph? Right there at 2. But notice what kind of dot there? Is there a solid line going through there, or is there an open dot there? There's an open dot there. So you'd think it was 2, but really because the dot is open and there's no line going through that, we're going to say it does not exist. There's no value there. It's an open dot. All right, and then let's find f of 1. F of 1 is over here. Where does it hit on the graph? There and there. Oops, but one's a solid dot and one's an open dot. Well, it can't count the open dot, so it has to come up here to the solid dot. And the solid dot is right there. What's the y value there? It's at 4. All right, let's find f of 6. So that where is, on your graph, where is it going to hit where you got a solid line or a line going through there, a solid dot or a line? Well, looks like right there, right? Your value there for x there is 6. What's your y value? It's 2. Now, how come I didn't pick this one up here at 5? Oh, because that's an open dot there. It's not going to work there. So I'm not going to pick 5. I'm going to pick the value there of 2. All right, so find the domain and the range of the function. Domain values are the x values that work for the function. So your x values here, if you look here, I kind of usually go toward the middle here of the graph and kind of look what's going on. So going to the right here, it looks like it goes on forever and ever and ever. So it just goes on forever toward the negative direction. This is going to go on forever and ever toward the positive direction. So your x values for this one, like here, is going to be all reals. Remember, you're looking for the x values that work. So they're all real numbers. Your range is what works for your y values. What can we limit our y values? Can we see a limitation on the y values? Yeah, I can. It's not ever going to go below this point right there. Your smallest y value is going to be there at -1. So since my smallest y value there is at -1, I'm going to say y has to be greater than or equal to -1. Because after there it's at -1, then it's just going to keep going up and up and up from -1. It's just going to keep getting bigger and bigger. If it was to go down, then you'd say y is less than or equal to -1, but it's going up, so we're going to say it's greater than or equal to -1.